Yeah, then we shall continue. So yesterday I had started with a new chapter, as you all remember, haloalkanes and haloarenes. So quickly let me revise only important things I'll be revising now. So if you remember what are haloalkanes, what were haloalkanes and what were haloarenes? Haloalkanes, and then you have studied about haloarenes. Haloalkanes are the one which are formed by replacing if you have a hydrocarbon now or aliphatic compound. Okay, aliphatic hydrocarbon I am taking. So if you have aliphatic hydrocarbon, from there if one hydrogen is replaced by the halogen, one or it can be more than one, all of these could be replaced. Okay, so if you replace the hydrogen by the halogen, yeah, that is a haloalkanes in aliphatic. Okay, this comes under aliphatic. Same thing, students, if you are doing this in aromatic compounds, like for example benzene, which has all the 6 carbon, and attached to that carbon they have hydrogen. Okay, so there is 6 hydrogen attached to the carbon here. So if this hydrogen is replaced again, if this hydrogen is replaced by the halogen, then that will be called as haloarenes. Done, no? This much you have understood, and this happens in aromatic compounds. If you do the replacement in aromatic, that's haloarenes. If you do that in aliphatic, then that is haloalkanes. Generally, how do you represent? How did I tell you to represent this generally? After replacement, what you get is CH3X. Correct. And here after replacement, what you get will be like benzene, and then instead of one hydrogen, there's a halogen. Yeah, so generally this is CH3X. So generally, how can you write RX? Very good, correct. RX, where R stands for this is a alkyl group, correct? Methyl group it was. So generally when we write, it is called as alkyl group, because depending on the number of carbon atom, there are different names given. No, alkyl group has different names for it. And X stands for the halogen group, the halide group. Okay, so alkyl halide is the common name, no? Alkyl halide. Alkyl halide is a common name for this. And this could be represented as ARX, where AR stands for aryl group, aryl, and X stands for the halogen. Yes, excellent. So I hope it's clear, it is understood. This part was clear. This is also called as aryl halide, the aromatic aryl halide. Then we had classification. So in the classification, the first type of classification was how many, depending on how many number of halogen atoms are present. Yeah, depending on the number of halogen atoms. If there is one hydrogen replaced by one halogen, okay, if you replace one hydrogen by one halogen, one X I'm writing, then that is monohaloalkanes. Monohaloalkanes, monohaloarenes. You know that. I'm not writing and I'm not going to show it. You can just refer your book. If you do two replacement of hydrogen by two halogen, then that is dihaloalkanes or dihaloarenes. If three hydrogen is replaced by three halogen, then that will be categorized under tri. Okay, so more than 3, 4 and all that, you can even call them as poly. Yes, very good. Correct. So that was one kind of classification based on the number of halogen atom. Then we had based on the halogen which is attached to the carbon, based on that hybridization, the carbon's hybridization. Correct. That second classification was second, and the third classification was those of those categories. So in that second classification, you have seen that halogen which was attached to the carbon, this carbon was sp3 hybridized. And the third classification was the halogen which is attached to the carbon, that carbon was sp2 hybridized. Agree? Yeah, sp3 and sp2 hybridized. So in this you had three. One was a alkyl halide, and then we had a allylic halide, allylic, and then we had benzylic. Okay, we had benzylic. So these were the three. In alkyl halide, you just saw halogen is attached to the alkyl group. So this R group is the carbon group. No, so that carbon is sp3 hybridized, which had further classification, which had primary, secondary, and then tertiary. If there is one R group present, then that's primary. If two R group, then that is secondary. If three R group, tertiary. Okay, so let me not go. You know already. Now allylic. What was the allylic one? Halogen was attached to the carbon. This carbon was sp3, but in turn that carbon was attached to carbon-carbon double bond. So which was sp2 hybridized? That was allylic. So it is for aliphatic compound. See, it is for aliphatic compound. Carbon is sp3 and that was attached to aliphatic compound only. Okay, but then they've had a double bond. Carbon-carbon double bond was there. sp2 hybridized it was. Benzylic was what, students? Halogen was attached to the carbon. That carbon was sp3, but then that carbon was attached to a benzene ring. Okay, aromatic ring. That was benzylic. Done. So these were the three classification. Then we came to sp2 hybridized carbon, the halogen which is attached. The carbon was sp2 hybridized. In that we had two classification. One was aryl halide and the other one was vinylic halide. Correct. Vinylic and aryl. Vinylic was what? Halogen was directly attached to sp2 hybridized carbon. Direct carbon-carbon double bond. This was sp2. Again, this is for aliphatic, okay? Aliphatic it is. Halogen attached to carbon which was sp2 hybridized. Direct attachment to sp2. And here halogen was attached to benzene ring. Done, no, students? I hope you don't have any doubts. Do you have anything to ask till here which was done? No doubts, no? After revising for a day, do you have any other doubt? In aryl halide, that halogen could be anything. Again, it can be fluorine, chlorine, bromine or iodine. Any halide. Fluoro, chloro, bromo or iodo. Huh, halogen is, shouldn't, yeah, correct. It should be connected to sp2. It is sp2, no dear. See, why in aryl halide? It is sp2, no? Carbon-carbon double bond, no? Benzene ring if you take, double bond, no? Every carbon over here is having a double bond. You see, this carbon has a double bond, see? This carbon has a double bond. See, this carbon, double bond. Every carbon you see, if you check on every carbon, they have a double bond here. So double bond means sp2, no? Yes. So halogen was directly attached to sp2, but then that was an aromatic ring compound. And here it is aliphatic compounds. Done, no? No other doubts? No other anybody else who is having any doubt? Shall I proceed? Then we went for IUPAC nomenclatures. IUPAC nomenclature and common nomenclature we had, no? In nomenclature, you had two categories. One was common name and the other one was IUPAC name. Common name, then we had IUPAC name. Common and IUPAC. Common name was alkyl halide, and aryl halide. For aromatic compound, aryl halide. For aliphatic compound, alkyl halide. IUPAC name are chapter heading itself. Haloalkanes. If it is alkyl group, it is haloalkanes. If it is aryl group, then they are haloarenes. Then we took few example and we have solved. I hope that also is clear. Anything, any compound which you want to like ask how to do it, any doubt is there where you are not able to follow the IUPAC thing? Shall I give you one compound and you'll try naming it? Let's see if you're able to do it. Okay, try doing this. Only IUPAC. I need only the IUPAC. Don't go for the common name. IUPAC, you tell me. Yes, what is the name? Everyone? Only IUPAC I need. I don't need any common name. You just give me IUPAC. Okay, I could see few of you have answered. Very good, very good. Bromo. See, the one who has given me the answer as bromopropene. That's the correct answer. Bromopropene itself is the answer. Very good. See, I'll tell you how to name this. Don't get confused. When you are numbering it, how will you number students? How will you number this compound? Bromine is attached to the carbon which is double bonded. So you should get one number for this carbon, no? You should give one number for this carbon, second number for this. Yeah, from right to left you will go because see double bond is there on this carbon plus a halogen is also attached. So that carbon will get first preference. Correct. That carbon will get first preference. So now on the first carbon, what is a branch? Bromo is a branch. So bromo. So it will be bromo. And then you are having 3 carbon atom, but there is a double bond in the first position. 3 carbon means prop. Double bond means in. So 3 bromopropene. That's it. No doubt, no? Did everyone get the same answer? Few of you have replied. Very good. And that was correct. Okay, one or two answers you have just little changes you have done. So just make a note, okay, where you have gone wrong. Okay, now tell me what will be the name of this. This, I want you all to give me the common as well as IUPAC name. Common as well as IUPAC name. Yes, very good. That's correct. Common name is correct. IUPAC name, dear. Everyone, reply quickly. Yes, very good. Correct. See, few of you are replying. Very good, very good. Yes, 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 yes. Correct. Somewhere, some of you are missing the prefix. Huh? So careful. Be careful with that. Don't miss the prefix. Some of you are missing the prefix. Very good. Correct. So common name is, the position is 1 and 4 position, no? Opposite position. So that is para position. Correct. Para, after writing para, what you are supposed to write? 2 bromines are there. So dibromo it should be. So don't miss that di there. Yeah, so para dibromobenzene. Para dibromobenzene. And when you are writing IUPAC name, the only change what you are going to do is with the position. The numbering of the position should be mentioned. 1, 2, 3, 4. So 1, comma 4. First position and fourth position you are able to see 2 bromine there. So 1, comma 4, both the position should be mentioned. Then come to the prefix. Then di. Dibromobenzene. So it is same, you see, the name is same. Only the difference you find over here. This is para and here 1, comma 4 is mentioned. That's it. Okay, got to know? Got to know any problem, students, in naming these compounds? Now, one more category which I wanted to name. Let me take that also. See here, this one. Benzene with the CH2 and then Cl. How to name this? It is little different, no? So don't go on counting the number of carbon atom. So that's not the correct way. If you see here, see this properly. you are having chlorine attached to CH2 group. And then that CH2 group is having one benzene group. So now see here, when you are naming these kind of compounds, it is not a continuous carbon chain. Yeah, very good. Benzylic halide, yes. Benzyl chloride it is. Okay, benzylic halide, yes, that's correct. So now this one's name is benzyl chloride, benzyl. Benzylic is the common denotion we use, but when you are naming the compound, it will be benzyl chloride. That's correct. That is a common name. Okay. Benzyl chloride. Because you could see here chlorine is attached to sp3 hybridized carbon, which in turn is attached to the benzene ring. So those are benzyl groups. CH2 with benzene is benzyl group. Okay, now let me come back. When you are naming the IUPAC, when you give the IUPAC name to this compound, what are the things you need to keep in mind? Can you take here benzene and then name it just like that? You can't take benzene, students. It is not these kind of compound where you are having benzene attached to chlorine. It is not of those category where you can write as chlorobenzene. Here you can't do that. You can see here chlorine is attached to CH2 group, which in turn is attached to a benzene. So that means this CH2 becomes the parent here. Okay, because it is not a continuous carbon chain. No, one is the ring and the other side chlorine is there. Okay, so then this becomes a parent. So to that parent, that CH2, one group attached is the benzene, which is coming as a branch, and one more is the Cl, which is coming as a branch. Keep in mind, it should be taken in that way. If there is a CH2 coming in between, or CH2 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 like that, a chain comes in between, okay, then that chain should be taken as parent. The rest everything comes as a branch. The rest everything should be taken as a branch. So here this benzene will become a branch and Cl will become a branch. And remember, when benzene becomes a branch, the name for that is phenyl. Okay, when they are taken as a branch, the name has to be given for that. Like when CH3 you take as a branch, that is called as methyl. Similarly, when benzene is taken as a branch, the name is phenyl. Phenyl, remember, okay? Phenyl has again one hydrogen less than compared to benzene. Is it clear? So this is phenyl group and one more group is Cl group. So both are branches. Now out of this, which should be named first? Phenyl and chloro, both of them are branches only. But which one will be named first? Go according to the alphabetical order. Yes, very good. Alphabetically, Cl comes first. C comes first. P comes afterwards. Okay. So it will be chloro and then phenyl, chlorophenyl, and then see the number of carbon atoms. CH2 has how many carbons? CHC, only one carbon, correct? So that is a parent now. So it will be chlorophenyl methane. Okay, this compound is little different. Benzyl chloride when you are naming, so you have to take that benzene which is coming as a branch and the Cl group also should be taken as a branch. Did you follow how to give the name? Should I give you one more compound to name it? Just take IUPAC. Give the IUPAC name. Forget about the common name. See. Now this one you should tell me how will you give the name for this. You have to give me the name for this compound. Forget about the common name. I am not asking you the common name. I need the IUPAC name. Just to see whether you are able to follow it. This is a branch here. See, when you have CH2 group coming in between or a carbon in between, then this benzene, see this benzene is a closed ring structure, no? So you can't count carbon as 1, 2, 3, 4, 5, 6, 7. You can't count them like that because they are not of one category. Okay, these are benzene ring and the other one is a CH2 group, aliphatic. So aliphatic ones are having substitution of benzene. So these benzenes are taken as a branch. Okay, and even that Cl is a branch. What will be the name? Okay, few names I've got. Just check the numbering also. Check if you have given the correct number, students. When you are giving the number, because there are two carbon atom, no? Not one carbon atom. See, this you will give one number because Br is attached. This you will give second number. So when you are naming it, 1 bromo, yes, 2 phenyl, correct, 2. Second position is that phenyl group, you see. Second position is a phenyl group. So it should be 1 bromo, 2 phenyl, then count the parent carbon. Parent carbon has 2 carbon, so ethane, yes. So it should be 1 bromo, 2 phenyl ethane. That's the correct name. Ethane, because single bonded. Followed? Is it understood? That's all. That's all for the IUPAC naming. Enough. I think we will proceed with the next topic. Still, if you all have doubt, you can anytime come and ask me. Okay. You can take few of the example from your textbook, start working it out. If you're not able to give the name for them, come and ask me. Anyways, I'll be there. Now we'll proceed with the next. See, nature of this carbon halogen bond. What kind of nature do they have? Nature of carbon halogen bond. So if you see now carbon and halogen CX bond. See, you know C and X, in that X is the halogen. I'll write it down here once again. C and then X. X is the halide group and halides properties you know, correct? What kind of nature do they have? Are they electropositive or electronegative? Are they electropositive or electronegative? C and X, in that X is electropositive or electronegative? Yes, they are electronegative. So electronegative means what? How will they behave if they are electronegative? Correct. X is electronegative. Very good. They are electronegative in nature. Electronegative substance, how do they behave, students? What do they do if they are attached to the elements? Very good, correct. They will try to grab the electron towards themselves. They are never satisfied, the greedy ones, correct, no? So if you are having, and you know these bonds in the organic compound, the bond which is formed is always a covalent bonding. So they were supposed to have a shared electrons between them. So C and X is supposed to have the shared electrons between them. But due to the nature of this halogen, which is more electronegative, what they will try to do, they will try to take these electron towards themselves. So I am shifting this arrow mark towards the halogen. So this electron density which is there, more of the electron density will be towards the halogen and the carbon will try to lose it. Correct, no? So halogen will acquire partial negative charge and this carbon will acquire a partial positive charge. Agree, no? Agree with this? So that is the nature of CX bond. Like you are just explaining what kind of nature do they have. What happens over there? Polarization happens. This charge separation, what is taking place, that is called as polarization. You have learned all this. You know this concept. Now, just that you have to apply it over here in this particular category of compounds. So when you are having haloalkanes or haloarenes, you have carbon and then there is a halogen. Halogen being more electronegative, tries to attract the shared pair of electron towards themselves, giving partial negative charge to the halogen. And since carbon is losing it, carbon is less electronegative than compared to halogen, so they will lose it towards the halogen. So carbon will carry partial positive charge. So that's the delta charge. Delta it is, okay? Not S, it is delta. You know how to write delta. Partial delta like this, okay? Partial negative and the other one is partial positive. Clear, no? So this charge separation, what is happening is called as polarization. So anytime when the attack has to happen, the nucleophile will come and attack the carbon which is positively charged. Okay, if you bring any nucleophile which is having electron density towards them, easy, you know, to come and attack on the carbon which is positively charged here. Then this X might go as a leaving group. During the reaction time, how the reaction might happen, we are trying to explain that. Is it clear? Is it understood? The nature you have understood, much we don't have to study about this. You just have to know what is the charge they are carrying. Done, no? Okay, we shall proceed with the next very, very important part of this chapter. That's the preparation. Okay, so starting with the first one, methods of preparation, starting with first one, that is from alcohol. First preparation we are doing. So there are many ways you can prepare. Through alcohol, you can prepare different kinds of alkyl halide. Okay, now how do you write alcohol, students? Generally, how do we write alcohol? General representation of alcohol. Like general representation for alkyl halide is Rx. Alkyl and then halide. So how do we represent alcohol generally? R group should be there. Correct, no? R group should be there, no? R group should be there. ROH. That's the general way of representing. So I'll just write here alcohol. General representation is ROH. OH is just the functional group. When I tell you entire alcohol, it should have a functional group attached to an alkyl group. Only then they will be stable. Otherwise, it won't form a stable compound. No, that won't be a stable compound. Okay. So first method of preparation is by Grooves process. You can remember the name of this method also. This method is called as Grooves process. Okay, through alcohol you are going to prepare. So alcohol is made to react with the HX. HX. I can take HCl also here. Okay, you can make a use of HCl, HBr, anything you can take. So alcohol is made to react with HX. In the presence of anhydrous, zinc chloride, anhydrous ZnCl2. Okay. Now when these two react, so what will happen? During the process, what will happen? You see, if alcohol reacts with HX, see, every time when you are writing the product, no, most of the time it is a double decomposition reaction. So just to do charge separation, do the charge separation first and then take that positive charge with the another anion. I'll show you how it is. See, between R and OH, between R and O, which is more electronegative? O. Agree? OH is one negative ion, no? OH is one negative ion, correct? So, OH will carry partial negative charge, R will carry partial positive charge. Between H and X, X is more electronegative. So, X will carry partial negative charge. H will carry a positive charge. So, who will go with whom now? Who should go with whom if both of these are made to react? That OH minus will go with the H plus easily. So I'll remove it like this. And then this R which is there, which is positively charged, will combine with the X minus. So the product what you will get will be Rx plus H2O. Clear? Now what is this anhydrous zinc chloride doing over there? That will help you to break this R and O bond, is there, no? So it is just acting as a catalyst here. Okay. So it will help you to break this R and O bond. Okay, and we'll try to make this bond weaker so that easily this R can combine with the halogen. That's the job. Okay, and this entire process is called as Grooves process. I am not going to explain you the entire mechanism, is not needed for you. If you are able to write the product is enough. Okay, so R, just to do the crisscrossing, separate the charges. Once you know how to separate the charges, you will be able to write the product. Most of the time organic products are written like that only. Okay, just to do the charge separation, R is positive, OH is minus charge, H is plus, X is minus, so separate them. So Rx plus water. You can write one example for this. Let me take one example for this. Instead of R, what we can write, students? CH3 you can write, or C2H5 you can write. I am taking the beginning one, simple one. So CH3OH, general means what? You can prepare any alkyl halide using this process. So we write general equation, no? Others could be prepared using this method. Okay. So CH3OH plus, instead of X I can take Cl, HCl I can take. In the presence of anhydrous zinc chloride, ZnCl2. Okay, alcohol with the HX, just mixing alcohol with the HX. So instead of HX here, I have taken HCl. So I'll explain you with the help of example here. So what should happen? Between CH3 and OH, who will have a charge separation? O being more electronegative will carry partial negative charge. Agree? Methyl group will get a partial positive charge. Between H and Cl, H will carry positive charge, Cl will get partial negative charge. Polarization is happening. Now just crisscross them. Yeah, OH minus will go with the H plus. OH minus will go with H plus. Water you will get, and CH3 will combine with the Cl. So the product will be CH3Cl plus H2O. Okay, this is how the product is formed. Let me not go into more detail of it. And in the exam, no, either they will ask you directly Group's process, or what they do is they will give you alcohol, ROH plus HX. You will have to complete this equation and write the product. Okay, how the question will be asked in your exam. This is how they will ask. Done, no? Now give the name, students. What is the name of this? CH3OH, methyl alcohol. CH3OH is methyl alcohol. And the product formed over here, CH3Cl, that's chloromethane, correct? Methyl chloride is a common name. Chloromethane is the IUPAC name. Methyl, I'll write methyl chloride first because the methyl alcohol is a common name for alcohol and methyl chloride is a common name for CH3Cl. Chloromethane becomes the IUPAC. That I'll put in the bracket. For this one's IUPAC name is methanol. That I'll put in the bracket. Yes, over? Did you all finish? Shall we proceed with next? Okay, next one. From alcohol itself, the second, we are continuing, okay? Continuation from the alcohol itself, but then you are making use of PX3 here. PX3 is phosphorus trihalide. Phosphorus, making use of phosphorus 3 is there, no? So trihalide. By making use of phosphorus trihalide, you are preparing alkyl halide. Okay, so again by taking alcohol. So alcohol general equation is ROH plus PX3. Now again crisscross this and see what will be the product formed. That line, no? Okay, you mean to say when we are writing alcohol, ROH, you can write it like this also, dear. The only thing is we are just showing that bond. It's a bond, no? ROH could be written like this. But the only thing just to show that there's a bond, we write ROH. The bond between R and OH. There's a bond between H and then X. There's a bond, we don't show it. That's it. That bond itself shifts here, no? The shared electrons. These are nothing but the electrons what they are sharing. So that bond you are shifting here as X minus. And then here hydrogen will lose it. So we show positive charge. Same thing even here also. This if you shift because oxygen being more electronegative, they will try to take it towards themselves. So minus. Then R will lose it. So R plus. Clear? So there's a bond, but we don't show it. Both are covalent. Yes. Both the bonds are covalent in nature. Correct. Okay, fine, no? Clear? Okay, now you tell me in this, how will you write the product, students? Everybody. Again, oxygen being more electronegative, I can put a partial negative charge here. R, I can put partial positive charge. Similarly, phosphorus, you see, phosphorus will get a positive charge because halide is more electronegative. So this will get partial positive charge. This should get partial negative charge. What is phosphorus valency there? Phosphorus valency, you see, PX3 means what? PX3 means what? P will carry 3 plus charge. Agree, no? P is 3 plus charge and X is minus charge. When you cross them, you get PX3. Like how AlCl3 when you write. When you write aluminium chloride, AlCl3, what does that 3 mean there? That is aluminium's 3 plus charge and chloride was carrying 1 minus charge. Due to 1 minus charge, aluminium will take 3 chloride ion, no? Then it becomes AlCl3. So similarly, you see here now when you do double decomposition reaction, phosphorus will take how many OH minus? How will be that product formed? R will combine with 1x because R valency is 1 plus, X valency is 1 minus. So Rx will be formed. One product is this. Plus, when phosphorus combines with OH, phosphorus is 3 plus. So it will combine with how many OH? 3, no? So it should be written like this, POH 3 times, POH 3 times. But in your book, they have given as H3PO3. It is the same thing, no students. 3 hydrogen, 3 oxygen and 1 phosphorus, H3PO3. Why it is given like this? Because it's an acid. When you write the acid, we write H first, you know. That's the only reason. Otherwise, nothing much, okay? It is P with OH 3 times. And we don't balance the equation every time in organic, no? You need not balance the equation and you need not write the product. All the side product need not be written. If you want to balance now here, see there is 3 halogens. So we can write 3 Rx. Now it will be completely balanced. 3 Rx means here it should be 3 ROH. Now it's a correct balanced equation. But in organic chemistry, remember, if you don't balance the equation, they won't cut the marks. Provided if when there is a name reaction, you balance it. Just, you know, because it's a name reaction, few name reactions are there. So for that you do it. But for all the reaction, you need not sit and balance. They don't expect also. So you won't be losing your marks if you don't balance it. Was this understood? Copy this down and write one example as well. Below this, we will take one example and we will write. Alcohol with PX3. PX3 when you do, R combines with the X, P combines with the OH. So you'll get 3 molecules of RX and POH3, which I said could be written as H3PO3. That's how it is given in the book, which is phosphorus acid. Okay, this is phosphorus acid. Take one example and write. Instead of R, we can take C2. Now I'll take C2H5OH. C2H5OH, alcohol, ethyl alcohol, plus PCl3 we will take. Always practice with one or two example. It's always better. Because sometimes they will give you example and they might ask you to complete. Anyhow, it could be asked, no? So you should be prepared with all the possible ways. You shouldn't get confused at the end. So alcohol with PCl3. What will be the product? This will get partial positive. This will get partial negative. This will get positive. This will get negative. Positive, negative. So C2H5 will combine with Cl. So we will get C2H5Cl. Plus P will combine with OH. So POH 3 times. POH 3 times. If you want, you can balance it. If you balance, this will become 3 and this will become 3 here. Give the name. C2H5, common name I'll write first. Common name is ethyl alcohol. Ethyl group is there and OH group is there. So ethyl alcohol. And this one's name C2H5Cl. Ethyl chloride, correct? Ethyl chloride. What will be the IUPAC name, students? Ethanol, correct? Ethanol for 2 carbon and then chloroethane. Chloroethane. Students, is this screen visible to you all? Or am I audible? Just message and tell me. Am I audible? Not visible, but I am audible to you all. Okay. One minute, 1 minute. I think something went wrong over here. Now, visible, no, students? Everyone? Yeah. Quickly copy this down now. Yeah, copy this down.